Hi everyone! Today we're going to look into how to set up the basis for a two-player game with one VR player and one PC player, both using the same machine. We're going to use Unreal's multiplayer functionality to do this by essentially running two instances of the game on the same machine and directing each player to possess their correct pawn upon login, and then correctly handle input and replication across both instances. If that sounds complicated to you, don't worry. Everything will be explained in time. Just keep watching and we'll get through it in no time. So first of all, we're going to need a new project. You can use any template you like or even a blank template depending on what you're trying to do. For our purposes, I've used a VR template that already has the basic VR functionality programmed into it. The first step is to get our player pawn classes set up. If you started with a template, you'll already have one down, either your VR class like I have, or your other player class. If not, go ahead and set up your basic pawn classes as you normally would. I'm not going to go into how to do that in this tutorial, but you can look at the UE4 documentation for details. For our purposes, I've gone ahead and opened a third-person template, and I'm just going to migrate this player pawn right here. Migrate. Okay. Let's just go ahead and find our content folder and migrate. Awesome. We can close this because we won't need it anymore. Now we should have our third-person BP with our third-person character in here. Perfect. Now here's where things are going to start to get different. Because you'll be running two instances of the game on one machine and only one window can have focus at a time, you're going to need to route all the VR player's input through the PC player pawn. So let's go ahead and create input mappings for both players like you normally would. And for that, we're going to go to Settings, Project Settings, and then head over to Input here on the side. So we have our VR inputs here already. Let's quickly create some inputs for our third-person character. Essentially, you'll want to recreate whatever's in here that has warnings on it. I'm going to do that real quick, and we'll meet back up after that's done. Be sure to name your new input mapping exactly as they're named in the blueprints, or else you'll have to re-drag them in. Alright, so we've got all of our input mappings. This can come into play later, but it's not in our current scope. And I'm not using a gamepad, I'm using a keyboard, so this I don't really have to worry about. So I'm going to go ahead and delete the things that I'm not going to use. Alright, now if we hit compile, should be happy. We can close this back up. So this is where the differences come in. Because the PC player's window is the one that's going to be technically focused in the eyes of the computer, we're going to have to let the PC player handle the VR player's input and then pass it along to the VR player. So in the PC player pawn, let's open this guy up again, we're going to have to create events for every input type that we want the VR player to have access to. So the PC player inputs can be set up as you normally would, but we're going to take the VR player's input and paste it into here. So in this current template, actually the only input action that our VR pawn has is the HMD teleport. So we're going to drag this guy in here. And once we have this guy in here, we're going to head into our VR player pawn. So we're going to want to set up custom events that are going to act as this input action node would. So let's set up a custom event for call HMD teleport pressed. And we're going to make another one. Call HMD teleport released. And we can go ahead and hook these up to the existing code. And I recommend leaving this guy hooked up just in case the PC player decides to Alt-Tab over to the VR player's window and the VR player gets focused, all of their controls will still function. So just add these in, don't replace this node. So now that we've created these custom events, we're going to want to set the replication settings on them so that they run on both the server and the client. So you're going to want to go to each one, go over here to Replicates, and select Multicast. So let's take a minute to talk about replication. An important thing to understand about multiplayer functionality in Unreal is that each game instance is its own separate environment, and things don't replicate by default in most cases. Replication is probably one of the most confusing concepts in UE4, but let's just try to break it down. There are three main things to remember. 1. By default, anytime any code is run, it only makes changes to its own instance. Let's say you have a blue box that both players can see. Something happens in the client instance that triggers the box changing to the color green. The code that was triggered in the client instance will only change the client's box to green, while the server's box stays blue. 2. To get something to happen on both instances, you need them to talk to each other using a special kind of custom event called a remote procedure call. The way to do that is by choosing the right replication setting on your custom events. Multicast runs the event locally, as well as replicating it to every other client. This one can only be called from the server. This would make sense for something like starting or ending a match, for example. Run on server is called from a client, and it basically tells the event to run only on the server. This might be useful if a client needs to tell the server to update a leaderboard or something like that. Run on owning client is called from the server and tells the event to only run on whichever client owns the blueprint that that event is on. This might be useful if the server has to tell the client to update some information in their HUD, for example. And last but not least, you can only use RPCs in an actor that specific instance owns, which in a client instance's case tends to only be the player character and player controller. This means that if a client wants to tell the server to do something, like change the box from blue to green in our earlier example, the client instance of the box has to tell the client player character, who can then call an event on the server to change the server instance box to green. Anytime something isn't replicating right, make sure to revisit these guidelines and see that you're following all three. Understanding replication and its limitations is crucial to making a functional multiplayer game, so definitely make sure you got this going forward, or at least be prepared to learn through trial by fire. Let's go back over to the third person character. So we're going to create a custom event here for each VR input, and I'm going to call it call HMD teleport pressed and call HMD teleport released. And for these two events, you're going to want to set the replication settings to run on server. And then from here, this is where we can call the VR player pawns custom events. So what I like to do in these two-player games is whenever a player pawn spawns, it automatically looks around for the other player and saves that player's actor to a variable so that you can reference it later. So let's actually do that now. We don't have a begin play yet, so let's put one here. And let's go ahead and get all actors of class of our HMD locomotion pawn. And out of those actors, we're going to get the first one we find, because there really should only be one. And we're going to save it to a variable, and we're going to call it VR player. And because the third person character will always spawn second, you don't have to loop through this code, because when it spawns there should always be an HMD locomotion pawn already in the world. So now that we have our variable, let's go up here and drag it in. And we're going to drag out of it and get our custom events. Pressed. And released. So now let's take a minute to explain the replication settings that we've used on these custom events. So what's going to happen is the VR player is going to spawn first. So that's going to be player 1. They're going to act as the server. And then player 2, the PC player, is going to spawn second, connect to the server, and they're going to be considered the client. So now, when the client version of this player character receives input from the motion controllers, we can go on to call these custom events, which will run on the server instance of the player character. And since at that point they'll be running on the server, they're free to call the VR player character and pass on the input. So to finish this up, we're going to call each custom event from its correct input. And now we've finished setting up the input mappings, which should allow you to maintain focus purely on the PC instance of the game and still receive and handle the VR player's input. Unfortunately, we can't test this until we finish the next step, so let's go ahead and do that now. What we're going to want to do is set up our custom game mode. So let's hit save all, good practice to get into, and we're going to create a new blank game mode. So let's go to add new, blueprint, blueprint class, and we're going to select game mode base. We're going to call this my game mode, and let's open her up. So first of all, we're going to fix some of these defaults. So for the default pawn class, we're going to select none. This is because the pawn class is going to depend entirely on which instance of the game you're running. Therefore, we're going to let it be decided on a per instance basis. So now let's head over to our event graph, and we're going to create a new variable and call it player index. And we're going to make this an integer. Basically what this is going to do is this is going to keep track of who is currently being handled, or how many players have been spawned. So in the event graph, let's get rid of this, and we're going to need a post login event. This essentially runs as soon as you connect. Here's where we're going to handle the assigning of pawns to each client. So first we're going to spawn our actor. So let's spawn actor from class. And we're going to do something. Depending on which player we're currently handling, we're going to spawn a different actor in a different location. So let's get a select here. We're going to use the player index to make this selection. And we're going to plug this into class, so it'll give us some class options. So if the player index is 0, that's the server, we're going to want to spawn an HMD locomotion pawn. And if the player index is 1, that's the PC player, we're going to want to spawn a third person character pawn. We're going to want to do the same thing for our spawn transform, because we want to spawn them preferably not on top of each other. Let's use the player index. And here's where we can make some transforms. Now it's time for some important notes. First of all, note that at least on the HTC Vive, the center of the playable area is always going to be positioned at the world origin, which is 000, at least at the beginning, regardless of where the pawn is initially spawned. So either design around this or somehow teleport your pawn right after it's been possessed, ideally masked by a fade-in or something similar. Also note that the VR player must be spawned and possessed first, because the headset will only recognize the first game instance's display. Therefore, the VR player can't function as the second client, so it has to be the server. And third, note that the pawns don't necessarily have to be spawned in. They can be placed manually in the world and simply possessed upon login. Either way works, but I prefer spawning as a defensive coding mechanism in the hypothetical case that more than the planned number of clients are attempting to log in for some reason, like if you accidentally run 3 instances of the game. This way, the game will gracefully spawn a pawn for each client instead of just failing when it can't find enough pawns to possess in the level. To support that, we're going to set the value range of this variable from 0 to 1. That way, if a third client tries to log in and increment the player index, it's just going to be clamped to 1, so these select nodes will still work properly. So for the purposes of this tutorial, let's see where we want to spawn our characters. So just to test this, I'm going to drop a pawn into the level, set this to 0, 0, 0. So the VR player is not on a floor right now. This is the VR template startup map. I'm going to quickly just make a more simple, friendly space for us to test our game in. We just make a big floor. Go ahead and move it down. Alright, that's decent. So the VR player is going to spawn at 0, 0, 0, and let's go ahead and let's just see where we want our third person character to spawn. We can have him spawn, let's just have him spawn like right behind us. So if you prefer this not to be hard-coded, you can drop some kind of world marker in here and then reference its position. But for our purposes, this works just fine. So after this, we're going to want to possess the pawn that we just created. So let's go ahead and cast a pawn. And then we're going to want to drag out from our new player and possess our player pawn. Bring this over and possess this pawn. After this, we're going to want to increment player index so that the next person who spawns in will be handled appropriately. So one important thing we can't forget to do is to set the game mode override in world settings to our new game mode, my game mode. If not, nothing we just did will take effect. So let's do that. So there's actually one more thing that we need to do before we can test this, and that is to remove all influences of the head-mounted display from our third-person character. Currently, you'll see that if we try to test it, the head-mounted display just controls both cameras, and that's not what we want. Let's go ahead and quit. We're going to open up our third-person character, and you're going to want to click to your follow camera. This is an important checkbox that took me a while to find, so this is why I'm emphasizing it to you. And we're basically going to want to uncheck Lock to HMD. This basically means that the camera is going to follow the position of the head-mounted display, which we definitely don't want. So now, as you can see, we have a separate camera for the HMD that can look around. And if we switch over to the player 2, they can also look around and move, and the VR player can see that. And if the VR blueprint had some sort of physical mesh in there, we would be able to see that in this view as well. And we can actually do that here real quick. So let's just minimize this real quick and head over to our VR character viewport, and let's drop a shape in there. What do we want? Let's just put a sphere. And we can drop an arrow in there too. I think they're actually... And let's quickly go to event graph. Let's find our event tick. We'll add another execution pin to the sequence. We're going to set world, location, and rotation. Let's put this down here. We're going to reference our camera. Alright. Now, just to make sure that the other player can see this movement, we're going to go ahead and check component replicates on our root, on our sphere, and on our arrow, just for good measure. Oh, and let's make sure to set replicates on our camera too, since that's what it's going to be following. Alright, let's check it out. Alright, cool. So now we got a VR player that can look around at us. Let's go ahead and quit. Now there's one more important thing that's pretty basic to the game that you might want to implement, and that is replicating your player pawns across the instances of the game. So in order for each player to see each other's actions, they have to be replicated across the network. Even though we're technically local in this scenario, it still has to be replicated because it's two separate instances of the game. So to do that, we're going to have to go to our class defaults in both the VR and the PC blueprints, and in the replication section, there's a couple important checkboxes that we need to check. Namely, replicates, which means that it will replicate. Replicate movement, which means that whenever its location changes, it'll replicate that. And in this case, always relevant. This basically means this actor will always replicate over the network. It's recommended to only check always relevant on things that are crucial to your gameplay. Because VR can be demanding and we're running two instances of the game, it's possible that the engine will need to resort to performance-saving methods to maintain an acceptable FPS, depending on your hardware, of course. And one of the methods it uses is calling any non-essential replication requests, so it can gain some processing power in exchange for smaller things not replicating, like certain particle effects or background and flavor animations. That's the kind of stuff that you wouldn't want to check this on. Or in an actual network scenario, if there are connection issues, this would help the engine prioritize what to drop first. But this is important in cases where, you're giving the player some important information that's relevant to their decisions in the game or whatever. So on player pawns, I generally check always relevant because I feel like that's pretty important. And you're going to want to check these 2 or 3 boxes on any actor or component that has animations, material changes, movement, or other appearance-altering code that's specific to that blueprint, that you want both players to see, of course. So let's go ahead and do that on the VR character as well. Let's go to class defaults and head to replication. And replicates and replicate movement are checked, so we just have to check always relevant. Looking good. Alright. So that is pretty much it for the scope of this tutorial. Now you have at least the basic foundation of a 2-player PC VR co-op game. We went over how to set up player pawns so that you can route the VR input through the PC player. We set up the game mode to handle spawning player pawns as each player comes online. And we talked about replication, went over how it works, some of its uses, and how it applies to this particular situation. Using these basic concepts, you should be able to theoretically move forward and create an awesome asynchronous co-op game using a PC and a VR headset. If you want to see an example of this technology, definitely check out my co-op cooking game Salamander. I'll drop the links in the description down below. And if you have any questions or concerns, leave a comment and I'll definitely try to get to it. Or if there's anything else that you'd like to see me cover, let me know that too, and I'll see what I can do. Thanks so much for watching, and remember, every day is a good day when you learn.